Okay, hi everyone. Okay, I'm going to show you a couple of new things today. These are called the double angle formulas. Formulae, more correctly. Before I do that, I just want to remind you of the two identities that you know about so far. So we know that sine squared theta plus cos squared theta is always equal to 1, no matter what theta is. You can check that on your calculator if you want to. And we also know that tan theta is sine theta over cos theta. So those are always true. That's why it's got three triple equals. Those are the two fundamental identities that we've learned so far. We're going to use those in a bit. Oh, that wasn't nice. Try that again. Okay, cool. So here, see, if we know what sine 15 is, it turns out we can actually work out what sine of double that is using another formula. You know, ordinarily you wouldn't be able to work that out, right? Because they're different numbers, and it's not the case that sine 15 is just double. Sorry, it's not the case that sine 30 is just double sine 15. In fact, let's just type it in just to make the point. So sine 30 is a half, and sine 15 is 0.26. So you can see that it's not quite, well, it's not the case that sine 30 is just twice sine 15, because sine isn't linear, remember, it's a curve. It looks like that. But there are ways to do this kind of thing. So it turns out, and I'm not going to show you the proof for this, but there is a geometrical proof, but it turns out that to get sine of double an angle, what you do is you take 2 sine of the angle times by cos of the same angle. So for example, sine, what did we say, 30 is the same as 2 sine 15 cos 15. We can just check that out by typing in 2 sine 15 cos 15 on the calculator. Comes out as a half. So this formula does actually work. So that's called the double angle formula for sine. And there's only one of those, and that's the only one you have to know about. So let's just label that double angle formula for sine. And there's also one for cos, but the cos, in general, cos tends to be more complicated always than sine for some reason, and I'll show you why. So cos 2 theta, the formula is cos squared theta minus sine squared theta. So this time you got squared. So that's fine, I mean, we can use that, but there are situations where there are more useful forms, so I'm going to show you how to get those. First of all, let's just put a box around it. That's the double angle formula for cos. Okay, but if we apply this rule here, we can actually get some other forms of it. So we could say, let's just go back to here. Hopefully you'd agree that if we take the cos squared to the other side, we could say that sine squared is equal to 1 minus cos squared theta. And similarly, if we did the same thing with the sine squared, we could say that cos squared theta is equal to 1 minus sine squared theta. Now these are really useful. We'll use these later as well. So here we could say that cos 2 theta was equal to cos squared theta minus, and then we could substitute in, instead of sine squared theta, we could say 1 minus cos squared theta. And then we could simplify that. What we would have is actually cos squared minus 1 minus cos squared, so in other words plus cos squared. So we'd have cos squared plus cos squared, which is 2 cos squared theta minus 1. And that is the second form of the double angle formula for cos, which is useful in the situation where you don't want to involve a sine. So you see it doesn't involve any sines. And you could probably guess what the second version would be. We'd do the same thing, but we'd substitute out that cos squared there. So we just say cos 2 theta equals, instead of cos squared theta, we would say 1 minus sine squared theta minus another sine squared theta, and that would give us 1 minus 2 sine squared theta. So you can see there's a kind of symmetry about these two. And there you go. So there are actually 3 forms of the double angle formula for cos, but only 1 form of the double angle formula for sine. And in the next video I'm going to show you some applications of these double angle formulas to take our trigonometry solving to the next level. Okay, thank you. See you in a bit.